Hello friends, welcome back to my channel. Please like, subscribe and press the bell icon to get notified of any upcoming videos. In today's video, I'll be taking another problem on 2D array. This problem has been asked in multiple companies like Google, Amazon, Microsoft, etc. The problem statement is very simple. It is to rotate a square matrix by 90 degrees, either clockwise or anti-clockwise. This would be clockwise and this would be anti-clockwise. But there's a simple twist that makes it very interesting, and the twist is that this has to be done in place without using any extra space. First, let's understand what is the meaning of square matrix. So the algorithm that I'm going to explain will work only for a square matrix. Square matrix means the number of rows and the number of columns have to be the same. Let's start with an example and first understand how to actually rotate a matrix on pen and paper. So I have taken two examples here. This is a square matrix of 2 by 2 and the other one is a square matrix of 3 by 3. So I'll be going with rotating this matrix by 90 degrees anti-clockwise. Okay. So I'll be explaining it in that fashion. So what will happen if I rotate this matrix by 90 degrees in the anti-clockwise direction? So what will happen is 1 will come here, 3 will go here, then this 4 will go on the upper side, then this 2 will come at this position. So this is how the matrix will look like after being rotated by 90 degrees anti-clockwise. Similarly, let's see how a 3 by 3 matrix will look like when it is rotated 90 degrees. So when I am rotating it 90 degrees anti-clockwise, what will happen? 1 will come here, then 4 will go here, then 7 will come here. Similarly, 8 will come here and 9 will go here. Then 3 will move at this position, at position of 1, and 6 will move at the position of 2. And then the remaining ones are 2. So 2 will come here and 5 will still be at its own position. So this is how the rotation of a 3 by 3 matrix anti-clockwise by 90 degrees will look like. Now there are two parts to solve this problem. The first is how we are going to achieve this is we are going to reverse the numbers for each row and then we are going to transpose the matrix. This is how we will be doing it in place. So the first step is reverse each row and the second step would be the transpose. I'll explain what transpose is as we come to that. First, let's understand how we are going to achieve the reversal of each row. I'll be going it with a 3 by 3 matrix. That will be a little easier to understand rather than 2 by 2. So when I'm saying we are going to reverse each row, let's start with the first row. So how will the reversal of first row look like? 3, 2, 1. Then it would be 6, 5, 4, 9, 8 and 7. Okay. Now, what if this would have been a 4 by 4 matrix? Let's say if it would have been a 4 by 4 matrix. So the reversal of first row, how it would look like is 4, 3, 2, 1, 8, 7, 6, 5 and so on. Okay. I just want you to explain that when it is an odd number, the middle position remains at the same. Whereas if it is an even number, all the numbers get reversed. Okay. Now let's continue with the 3 by 3 example. This is how the reversal looks like. Reversal of each row. Now the next step is transpose the matrix. What do you mean by transpose a matrix is just draw a diagonal line and swap the numbers on the diagonal line. So how it will look like is, so I have drawn the diagonal line. Keep all the elements of the diagonal line at the same position. Okay. And now we are going to swap the other numbers. So 2 and 6 are going to be swapped. So here it would be 2 and then it would be 6. Then 1 and 9. So we are going to swap 1 and 9. And the last is 8 and 4. So 8 could come here and 4 would come here. So this is how the final result of rotating a matrix by 90 degrees anti-clockwise will look like. Let's confirm whether this is the one that we have seen in the beginning. 3, 2, 1, 3, 2, 1, 6, 5, 4, 9, 8, 7. Perfect. So this is the one. So this is how you're going to do. Let's convert it into the form of an algorithm, or how the pseudocode will look like for it. So I'll be writing two methods, one for the reversal of each row, and the other for the transpose. So let's start with the first, the reversal. So we have to reverse each and every row. So I'll be passing the variable I. Basically this means that row number, which row number you want to reverse. Then the other one would be the matrix. And the third variable I will be taking as the n, the size of the square matrix. I'll be taking two variables, start as 0 and end as n minus 1. We'll be having a while loop while start is less than end. Basically this boundary condition needs to be there. I am not writing boundary conditions for while n is greater than 0. Such things I am not writing. Okay, please be aware, while you're writing the entire code or entire program, please ensure to have such boundary conditions. What we are going to do is we are going to swap matrix of I and the start. Basically the first and the last number of that row. So I represents that row number, and start represents this first number, and end represents the last number, and matrix of I and the end. Once this is done, we are going to increment the start counter and decrement the ending counter. Okay, so while let's take an example when there are four numbers. So in the first step, I am taking this example only, 13, 14, 15 and 16. In the first iteration, 13 and 16 will be swapped. In the second time, 14 and 15 will be swapped. So it will look like this. And this is what the desired output is. 16, 15, 14, 13. The entire row has been reversed. Okay. So this is how we are going to write the reverse function. Now the other one is the transpose. I am not writing the driver function. Please do mention in the comments if anyone wants me to write the entire function. Here also I will be taking two inputs. One is the size of the square matrix and the other would be the matrix itself. So how do we transpose is, we have to have two loops, I equals to 0 to n, and then the other one would be what? J. Here I am going to initialize j with I and not 0, because as I have mentioned in the beginning that this, in the transpose we are going to swap the elements across the diagonal. So at every point j has to be initialized with I and not always 0. Okay. And then again j less than n, and then j plus plus, and again we are going to swap two elements. Now which two elements would be here? One would be the matrix of ij and the other would be matrix of ji. This is how we are going to access the two elements across the diagonal, and this ends the transpose method. Now in the driver function, what you are going to do is you are going to first call the reverse method and then you are going to call the transpose method. This is how you will be rotating a square matrix by 90 degree anti-clockwise. Now if you have to rotate the matrix clockwise, you can do the same functions apart from the in this we have reversed each row. You might have to do reverse each column. I'll leave that as an assignment. Please let me know if you are not able to do it. Mention in the comments. I'll help you. Thank you for watching the video. Stay tuned.